You guys are able to see my screen, right?
Yes, it's visible.
Yes.
Great. Thank you. So, Bismillah ar-Rahman ar-Rahim. For the last, maybe couple of lectures, we have been talking about refactoring, and I believe all of us now understand that, refactoring, the whole idea behind refactoring is that you do not change the external behavior of the code, but rather you change the internal structure of the code in such a way that the external behavior is not changed. And of course, you do testing to make sure that this is happening. And the whole idea behind refactoring is to make it internal structure of the code more readable, understandable, and as a result, probably you might even find bugs. It may help in your testing, writing better test cases, better understanding of the source code itself. So, today what we'll be doing is, we'll inshallah be finishing the discussion on refactoring by looking at some common refactoring techniques. And then at the end of the lecture, we'll be looking at what we call, some obstacles we believe there in the refactoring, and we'll just very quickly discuss about, what are the challenges we face typically in the industry when it comes to refactoring. So let's look at them. They are not difficult, by the way, at all, and they are usually there. These refactoring techniques are there for certain, code bad smells, right? Remember, I said that they're code bad smells, and those code bad smells are not actual, logic syntax or logical mistakes in the code. Rather, they are piece of codes which are potentially vulnerable to mistakes. Because of maybe lack of understanding, lack of clarity, or they being so complex and in such a way, written in such a complex way that you're prone to make mistake, right? So let's look at them one by one, and they are not that difficult at all. So first one we have is something called extract method. So and basically what you do is that if you have a piece of code like this, you are doing certain functionality, like in this case you're doing certain print statements, and this is one specific action you do, rather than putting them in each method. You do it again and again. you know why not you go on and extract a method out of it, like something like this, that you just go on and create a method called print detail, and it will do the printing, and you call this method within the piece of code you have. So as the name suggests, this is the first commonly used or very heavily used uh, refactoring technique, which is called extract method. Everybody got this one?
Yes, inshallah.
Inshallah. So probably, I'm pretty sure because you guys have probably seen the one or two or few of them in as part of your 205 as well. So probably, it will be even more easier for you guys. Again, the problem what we are trying to solve as part of the extract method is that, we have a code that can be grouped together, right? So basically solution is to move this code into a separate method. And like in this case, we're moving them into print details method. And why we are doing this refactoring, basically, because there are more lines, in a method. You have a lot of, a long method as such. This is like a potential code bad smell, that you have a long method. And since you have long method, you are still vulnerable to making mistakes. And then of course, if you extract them out as a separate method, it's more structured, better to read, more understandable, and furthermore down the track there are other benefits, like if there is some other piece of code, some other part of the class or within the same package or the same system which such kind of printing needs to be done, you don't have to rewrite the same line of codes again and again. All you have to do is basically just call this method. Everybody is on board with me on this? Everybody's
Yes.
comfortable with this, right?
Yeah.
Alhamdulillah. Now this is very simple, right? No rocket science here, to be honest, but it's very, very useful, right? And again, remember the IDEs we have help us and support us do this, right? So, all you have to do is basically apply it with a clear understanding that, it's being done correctly and it's not going to impact on your rest of the logic of the application, and go on and carry on and do it. Now, this leads us to the second one, which is again a very common one, which is basically the whole idea is to replace the temp with queries, right? So if you have a piece of code here, like, you're calculating a certain base variable, base price for a certain item, and then you are actually, using this base price to do a lot of calculations. You can replace the temp with a query, which means basically, go on and create a base price method and then use this base price method to do the calculations. Again, the problem we're trying to solve here is that, you replace the result of an expression in a local variable. So basically, rather than having this best price as a local variable, you move the entire expression to a separate method, right? And then you query, rather than querying that or using that local variable, you can start querying that method. And the whole idea behind this is that, if you do this way, it's actually kind of laying down the groundwork for you to apply the extract method, which we just looked at, right? And usually we apply extract method for a portion of a very long method. So, if you have a very long method and and you know and you want to apply extract methods on it, probably, the very first thing you can do is, first of all, replace them with queries, that rather than using the variables, local variables for these, create methods for them. And then, you can further subdivide the whole piece. Of course, again, this will compile. There is no doubt about it. This will work. But probably this is better from a reading perspective. This is better from an understanding perspective. This is even better structured, that if some other part of the code needs to do this base price calculations, no problems. It's now a method now. You all have to do is just call this method and you'll get the values. And of course, there's only one place you'll have to make a change. If you have to change, like, for example, rather than multiplying quality with item, maybe you have to also multiply it with 100 or something, I don't know, or 100%, or give some discounts or something like this, So it's only one place you're making a change. Everybody's on board with me on this?
Yes.
Is this
Yes.
distinct? Is it clear that what's the relationship between replace temp query and extract method? Because here, if you look at it, you're also extracting a method here, right? It looks like it as if you're extracting a method. So is everybody's clear with me, on board with me here, that how replace temp with query is different from an extract method?
Yes.
Teacher, can you repeat why we should do this?
Okay, why we should do this now? The reason we should be doing this is because, you have a local variable here in this case, right? The best price, right? We have this local variable here, and down this local variable, rather than having this local variable and using this local variable, we suggest that we move the entire expression of this calculation, right? Because at the end of the day, it's not just a variable like, you're defining, and actually you're doing some calculation for this variable as well, right? So it's recommended that we move this into a separate method and then query that method. And that's what the meaning is, replace them with queries, that, create method and query that method. And basically you're doing this because it's going to lay down the groundwork for you to apply the extract methods. And we apply extract methods because because we tend to apply extract method for the code bad smell, and that code bad smell is when you have very long methods. These two go hand in hand. The focus is an important point. Focus of replace temp to query is on local variables, right? While the extract method is the next step, where basically you try to divide the long methods into smaller methods. So it kind of lays down the work for you to apply extract method as well. Everybody's on board with me on this. Everybody's, this is not hard, by the way, but just we need to be, again, remember, keep in your mind that what's the idea behind refactoring? Why we are doing this? We're doing this to make it, remember that Martin Flower statement, which says that, a good piece of code is the one which humans can read. All right. Because the compiler will still compile this way, and if you look at under the hood, this compilation is exactly going to be the same way. All right, the results will be the same, the behavior is preserved, but at the end of the day, you're making it better structured, easy to understand, easy to read. Now, this takes us to the third one, which is, again, not difficult at all, to be honest. Similar to extract method, we have something called extract variable. That here, if you have some kind of, such variables which has some complex, it's reflecting a condition, for example, right? Like in this case, that these are the different conditions you have in your code, and rather than writing this, basically, why not you define them as a meaningful variables? So basically, this whole idea behind extract variable, that these complex number which is coming up here, an index based on a certain uppercase and then index of a certain thing, and you are checking that is less, greater than -1 or whatever, you can define and extract methods for them, variables for them, and then use those variables in your if conditions. And of course, which one is easier to read?
The second one.
The second one, actually, right? It's easier to read. It's more, more structured. Again, if you have to make a change, you have to just go and make a change here, and it will be reflected, and so on and so forth. Again, remember, I'm saying this again and again, but just to make sure everybody's on board with me on this concept that this will compile, this will do the job, but again, we are doing refactoring for making it easy to understand, making it easy and human friendly to comprehend the logic. Remember, at the end of the day, you want this to be written in such a way that you can read it, then it will help you in maintenance of the application. It will help you in testing, right? Easier for you to go on and write test cases, because remember, as a test case or as a tester, you will have to go and understand someone else's code first to write test cases, and this is far easier and clearer to understand than this one. So the fourth one we have is something called decompose conditions or decompose conditional. And we have, we usually recommend to apply this refactoring when we have complicated if then else condition statements. So if you have scenario like this and someone has written a piece of code like this, date before summer starts, or if the date is after the summer ends, then charge him a specific value, otherwise charge him a different value. Now I can decompose this condition and refactor it with something like this. So basically I'm creating a non-summer method, for example, then a winter charge method and a summer charge method. Is it easier to understand this one?
Yes, it makes sense more.
It makes more sense. Exactly, it makes more sense. It's clearer. It's there is no ambiguity now in this, right? And hence all the benefits which we're looking from refactoring are available to us. Of course, remember, there will be a method called winter charge, right? What will be the line which will be moved to winter charge from the original piece of code?
Else part.
The else part, or the so if it's not the if not the summer, this one, right?
Yeah.
And for this one will move to the summer one. Again, the benefits are very obvious in front of us, right? Now, the question comes, you know, why someone will write this way, right? Why don't he writes this way from beginning? What do you think? Why we will come to a situation where someone will first be write this way and then write this way, based on your own programming experiences?
For example, I do this first line just to get the idea, the whole idea, and test it. Okay. Then I see it and oh, I will need to refactor it. But after the testing, I refactor because I check if it's work, if everything is fine, then refactor it to make it easy.
Correct, correct. Now this goes back to the example, remember the three hats I discussed on Sunday, right? So when you're putting the hat of the refactorer, right, you are supposed to not add new functionalities, correct? And you are not supposed to add new test cases, but you can modify test cases, correct?
Yes,
Remember that?
absolutely.
Yeah, so basically, as I said, that first of, and then we also on Sunday discussed another important point was that when you do refactoring, you do refactoring when your code is stable, right? And you have tested it. So as you said, I write this piece of code to make sure that I satisfy the requirement and logic of it, and I test it and it works fine. Now it's time for me to go on and better structure it so that someone else who gonna read my code or he gonna use my code, it's more easier for him to use it, more structured. He can even call my methods and so on and so forth, right? And I think all of you guys do this anyway, right? You always try to get your work done first and then you refactor it. And but just to have to make sure that when you're doing refactoring, you're not supposed to add new functionality. Are we adding a new functionality as part of this refactoring?
No,
Not
absolutely
adding.
not.
We're not adding any new functionality. Adding or creating a new method doesn't mean we're adding a functionality. This is what I'm trying to highlight here. You're restructuring the internal code, which is the definition that you are allowed to restructure the internal code without changing the external behavior. And when we're doing this, when we are creating new methods, we are only restructuring the internal code. We're not changing the behavior. And how are we going to make sure that behavior has not changed? Again, we already have test cases here. We know their outputs. We're going to execute the same test cases here. And we'll make sure that the outputs are still the same. Now, what will be the case? As we said, we are not allowed to add new functionalities. It's very obvious we are not adding any functionality here. As part of that three hat example, we also said very clearly that you cannot add new test cases, but you can modify it. What could be the case where you might have to modify your test case? What do you think? Why you will have to modify your test cases?
Maybe because of the first place, there is an issue in my code, an error, maybe, and I didn't find it. Then after the refactor, I find it. Maybe.
Yes, yes, that could be one reason, right? Because as we said that as a byproduct of refactoring, as we said on Sunday, as byproduct of refactoring, we may find some hidden or masked bugs as well, right? Let's assume that's not happening, for example, right? What could be another reason why we might have to modify our test cases?
Maybe changed the parameters of
Exactly.
one method.
Exactly. See what's happening here. If you have a test case for this, maybe you will have to enter two values, right? Or some value here, right? A date, right?
Yes.
And you know, uh, and quantity and so on and so forth. And now probably, if once you have restructured it, maybe your input parameters for that test case needs to be changed. Or maybe given in a different order, maybe, right? There's nothing wrong in you to modify your test cases. It's still you're not violating any fundamental principle of refactoring. All you are not supposed to do is add new functionalities as part of the refactoring process. I think everybody's clear about this, right?
Yes.
Alhamdulillah. Now, similar to the extract method and extract variable, if we go on to a class level, we if we have long classes, a big class, then or large class, with the right terminology for it, a large class, then we can use refactoring and apply the concept of extract classes. And a class is doing work that should be done by two, we can go on and extract class out of it. Now, which solid principle to begin with it should be following? Or if you have a class which is doing multiple things, and as a result it's a large class, and you're supposed to go on and extract class refactoring, what is the solid principle we are violating? Which were the solid principle we were violating, and as a result we should apply extract class to solve the issue?
Single responsibility.
Exactly, single responsibility. Now, this is a very obvious case where extract class will be applied, that you have a single violation of a single responsibility, and as a result it's better to split them and create classes which are actually reflecting of their single responsibility. But there could be some other cases where you might not be violating single responsibility as such, but you might still like to extract classes, like in this case. Like, if you look at this class seems to be satisfying single responsibility, right? Because everything is about a person and so on and so forth. And I'm suggesting that maybe refactor it into a person class and a number class, or a telephone number class, right? And probably I'll even be doing this, to be honest. See, we are not violating as such a single responsibility, but we think that, okay, maybe why not we create two separate classes, split them out, extract class out of it. Now, let me give you another example, and probably this will be easier to understand. Now, see, if I have the same person class, right? And I have an address, right? Now, one possibility is that address is a string and, it just store the information, correct? The other possibility is that, you actually don't want to just store address as a single attribute or a single string. You're interested in the street name, house number, for example, right? Street number, the location, the city, the postcode, right? The country, so on and so forth, right? So you might be better off splitting this class into a person class and having a composition and having an address class. And this is, by the way, common. This happens a lot, right?
Yes.
Right. So extract method allows you to extract a class out of something, which you believe should be done in the two classes, for example. Of course, one is very obvious. Single responsibility. Is violating single responsibility, apply extract class, create separate classes. But even if it's not violating single responsibility, you might end up with the scenarios like these, where you might have to, have more details about a certain attribute, right? Like in telephone number or an address, and you're better off creating separate classes for them. Everybody got this one? Any questions on this specific example?
The method get telephone number. Why does it repeat it in the person and telephone number?
Okay. Probably should not be here to maybe, maybe should not be here, right?
Yeah, I think it's better now.
Yes, yes, yes. Probably it was a typing mistake. It's a good observation, yes. But are we clear on the concept?
Yeah.
Yes,
Great.
inshallah.
Inshallah. Now, similarly, there is another one which is called parameterized methods. It's a refactoring when you apply, for example, you have several methods who are doing the same thing, right? So you end up in a situation where you have several methods, like in this case, like you have a method called 5% rise and 10% rise. And then, you realize that, they're doing the same thing. So why not I go on and parameterize these methods, and because at the end of the day they're doing the same thing but with different values. So basically they're doing the same thing but different values. Why not I just go on and parameterize this method, something like this, rather than having 5% and 10% rise different methods, I'll just create a rise method with a percentage, right? Now as a concept this makes a lot of sense, right? And this is something you are quite aware of as a developer, and you've been taught about this. Now my question is, why we will even end up with this to begin with? And hence you will have to think about applying a parameterized method refactoring. Why this will happen to begin with? What are the different possibilities this may happen?
Maybe in the beginning, I needed to add like a method 5% raise. Then after a while, I think it's like I needed 10% raise. Then I
Mm,
added.
mm.
And
Yes, true.
honestly, Doctor, I think this is more suitable because when I do these two methods, I like make a boundary to not like add 15 or 20.
Mm-hmm.
So I think it's much better in some situations.
Mm-hmm. Uh, uh, well, yeah, that's an interesting one. Um, but usually it will happen is, of course, this is a better one to be honest, because it's more in one place, right? It's well defined. Whatever the percentage tomorrow, if you have to go on and change the percentages, you don't have to go on and change. For example, from tomorrow, if you change from 5 to 6%, right? All of a sudden, something needs to be changed from 5% rise to 6% rise or 2% rise. Then the main name might have to be changed as well, right? So probably this is still a better solution, right? But the question was, as I said, and I think you kind of answered that as well, that why to begin with, I'll come to this scenario, because it makes a lot of sense. You guys have been taught about this from your ICS 102, 201, 202 days, 202 days as well, right? And even from 205, and 215 lab that, create methods which are more generic in nature and so on and so forth. So why on earth I will even come up with a code like this? Why? Why a developer will do this?
Doctor,
Yes, please.
I think in the beginning of the development life cycle, the use cases only defined 5 and 10%,
Hmm.
but
Hmm.
maybe later on they added more percentages or they changed the use cases,
Hmm. Hmm.
therefore making the raise method.
Exactly. Now, this is one possibility. The other thing is, as you said, this is happening now. This happens a lot in Agile, to be honest. Now, in Agile, remember, you go on and take up a group of functions or features, right? And you go on and implement it, right? And there probably, when you look at this, those features were only talking about, say, you got to have a 5%, rise, right? So maybe as a developer I just went on and said, oh, 5% rise. Okay. Now when you go to the next iteration, next sprint, maybe, or 3 4 sprints down the track, you take another bunch of user stories, and there we have a 10% rise as well for a certain case, and you might end up with then writing that 10% rise. And as a result, later on, once the code is stable, you look at this and you said, I have two methods which are basically doing the same thing. So they are doing similar things, right? Only difference is they are taking different values, right? Why not I just go on and parameterize them? Okay, so this can happen. So this is not like that it can never happen, or it's a very bad programming on the programmer's behalf. You know, it can happen, especially in an agile environment. It tend to happen now, especially if you're doing a waterfall. Probably you might not even come to this stage because you know the whole requirements. You have seen the whole requirements as a designer, right? And you already have realized that there are multiple percentages, and as a result, I'm better off having a percentage, a method which can handle multiple values. So don't be surprised that you see such things happening because, especially in an agile environment, and that's what's the whole idea is. So it's a tool you have with you. If something like this happens, all we have to do is do something called parameterized method refactoring, and that's it. So are you able to visualize with me like where this can happen and what scenarios this can happen?
Yes.
Cool. Okay. Now, same thing can happen again, because in your agile environment, this could be happening that, you can have pull up or pull up fields or attributes and pull up methods as well that, you have two subclasses with the same field. So originally, maybe, you came up with a salesman class and then you came up with an engineer class. And then you realized, once your code is stable, you're doing now refactoring and you said, oh, they're doing the same thing. Why not I just move this, the name attribute up into the parent class, right? And again, this could be happening now. This is very unlikely that you will do this if you're doing like a waterfall model because you know the complete system. So probably, you're thinking about inheritance, you're thinking about, all the different attributes, and as a result, you probably will put them here to begin with. But if you're doing more like an agile environment development where basically, maybe in the beginning you only implemented a sale class and then you implemented an engineer class and both had names. So you went on and wrote a code, basically, it had names. And then when you come and the code is now stable, now when you come and refactor it, you realize, oh, well, why not I create a parent class maybe, right? Or maybe if I already have a parent class, why not I move these variables up there? So this is, another tool you have where you can pull up the attributes or pull up the methods. Even this could be done for methods. And similarly, on the flip side, you can even push them down as well, right? That, in the beginning, you may end up with writing an employee class where you believe the quota will be shared between the children. But then you realize that, oh, this is actually quota is not supposed to be here in employee, because when I look at this, engineer never has a quota, right? So you can push it down as well. So everybody is clear about this pull up and push down, situations?
Yes.
All right. So again, I said they are not difficult, to be honest. They are very, very easy. But these are the different potential vulnerabilities we may have, and we're trying to, they're not mistakes as such in the beginning, but they are potential vulnerabilities which may lead you to make mistakes, and hence you should refactor them to fix those issues. And this brings us to another very, very interesting one, which is, sometimes we tend to make a lot of mistake about this one, to be honest. That, you should not have error codes, right? Sometimes we tend to have error codes. Like in this case, we're saying that, withdraw method, if amount is greater than balance you will be returning -1. Otherwise, you'll be returning 0, right? Now, what's the problem with these error codes?
Not clear at
They're
all.
not, yeah, they're not clear at all. You have to assume. So if I have written this piece of code and I'm now showing this piece of code to you, you have to now go on and understand what I was thinking when I said -1. Is it that, I have, after the transaction of withdrawing the money, I have -1 balance, or is it means that, it cannot be done, right? So This is not recommended. Now, this is something we tend to do a lot, to be honest. Sometimes we just, don't pay attention to it. And this refactoring tool really, this replace error code with exception is a very good one. So rather than having a special code returning, you're basically advised to throw exceptions where applicable, right? And also give them meaningful names and, so on and so forth, so that, uh, it's clearer to the ones who are gonna use your methods or who are gonna read your methods that what's the meaning of -1 or what's the meaning of 0, what exactly you're trying to tell us. Again, this will compile, this will work. There's nothing wrong from a compilation perspective, but as a human person, as a reader, as a understanding of the code, this is far better, isn't it? And better organized.
Yes.
Okay, cool. Now, probably this is probably the last one, which is to replace parameter with explicit methods. Again, if you have methods that run different code depending on the values of a certain parameter, rather than having complex if statements, you are recommended to replace parameters with explicit methods. Like in this case, all you're really doing is basically you're setting height here, that if you're looking for height, then set the value of height. If you have a width, then you set a value of width, right? Depending on what value you're trying to set. Rather than, coming up with these methods which are doing different complex switch statements or if conditions, make separate methods, specific methods for them. Now, of course, if you're more experienced, probably you'll do it in the first go, right? But even if you're experienced, sometimes we tend to come up with this as a first version, and then you can always refactor it and replace parameter with explicit methods. Now, as a programmer, what are the common, as a programmer, what do you believe are the common areas we tend to make mistakes based on your own personal experience? As a programmer, of course, no programmer tries to make a mistake deliberately, isn't it? But when it comes to logic of an application, when you're trying to solve a problem and trying to write a piece of code to solve a specific logic, and it's more complicated, what are the common areas where we tend to make mistakes? What do you think?
Long Boolean expressions, I
Long
believe.
Boolean, exactly. Long Boolean expressions are very vulnerable. All right. And Boolean and if this else conditions are also very vulnerable, right? So these conditional statements are very vulnerable for us to make mistakes, right?
Yes, yeah, absolutely.
Anything else which is where we are vulnerable as programmers? Loops.
Long methods,
Long
loops.
methods, loops. We are very vulnerable to make mistakes, right? And if you notice, all of these refactoring are doing what? They're telling us don't have complicated logic statements, right? Don't have long methods, right? Create separate methods. And that's the whole message. And inshallah, when you're going to learn the testing, I always say that, as a tester, if you see a code like this, right, you as a tester will immediately become interested in it. Because it has complex conditional statements here. And, or many conditional statements here, not complex probably in this case, but many conditional statements here. And as a programmer, you can easily make a mistake here. Okay. So these are the few ones. By the way, there are many others out there, and you can have a look at them. But probably this gives you a bit of idea about what are the different refactoring approaches or methodologies we have available or techniques we have available to us. All of them are actually trying to help us better structure the code, make it easy for us to understand. Remember, we are doing this in such a way that we are not changing the external behavior. All we are doing is basically rearranging the internal structure of the code. And this is all these refactoring methods we seen today. That's exactly what they're doing. Now, refactoring, of course, has its own obstacles. It has its own challenges. First of all, is the complexity itself. It's a big challenge. changing a complex code, understanding a complex code is hard. Hence, once you're going to apply, especially if you're going to apply this online automated refactoring, then you need to understand your existing code first to make sure that you're not making a mistake here, right? So this is one of the obstacles to refactoring, that the code itself is complicated. If the conditions are so complicated, it will take you time to read it and understand it and make sure that when I apply a refactoring, I don't change the behavior, I only change the internal structure. And so this is one of the obstacles, but again, we apply refactoring to actually improve this anyway, right? So if you have a complex piece of code, complex system, for sure, I think it is advisable that at a certain stage you should do refactoring for it. And of course, another possible problem or obstacle is that when you do refactoring and things are complicated and you not understand them correctly and you just go on and refactor it, you may introduce errors, right? Because if you didn't understand the original piece of code and you applied refactoring, especially if you applied automatic refactoring, you can easily break it, because you need to completely understand the rippling effect of that change. And if the system was originally complicated and you didn't follow the good design principles you guys know now, like the solid principles and so on and so forth, if you didn't apply them to begin with, refactoring will be harder anyway. But if this is happening, you as a refactor, a designer, this is immediately, again, as I said, like in the previous slide, that if you see this as a piece of code in a tester, you immediately become interested in it. Yes, your life will be difficult, but you immediately become interested in it because you see, a lot of if conditions, a lot of loops, so on and so forth, complicated conditions, probably error prone. Something happens here. If you see something very complicated, you see something which is interdependent, they're not following solid principles, you as a designer, as a role of refactor, immediately become interested in it because yeah, I think we need to do it. It's worth doing it. And probably, these are more technical issues, but probably one of the biggest problem we face is the cultural one as an obstacle to refactoring, is that a lot of people believe that, and even the management will believe sometimes that, your responsibility is to write piece of code. Your responsibility is to meet requirements. Your responsibility to add functionality. Your responsibility is to make sure the function works fine. What's the point of improving the code? So people sometimes even question you from a cultural perspective, that what's the point of improving the code? What's in for me? Why I should do it? But am I able to convey this message to you guys that, refactoring is important, and when, at a certain stage you should be doing it?
Yes.
All right, so this is an important factor we have to consider, that yes, on a piece of paper, on a first look, it doesn't make sense that why I should do this effort. But to be honest, such improvements pay them in long term. Now, especially if you're doing agile environment, agile development, you will have to do refactoring anyway. Otherwise, you will end up in a piece of code which will be almost impossible to maintain. Now, of course, refactoring impacts performance. There is no doubt about it. Because if you notice, most of the time you're adding new methods, you're extracting methods, you're creating more classes. So for sure, it will have impact on performance. There's no doubt about it. But the good news is that, analysis tells us that it's only the 10% system, 90%. So if you focus on those 10%, probably you will get a better solution and an improvement in your refactoring. So basically, you can refactor that specific parts which needs changes, and you still don't make a lot of compromise on refactoring on your performance. Now, of course, if as a result of your refactoring, you come to a stage where you are now not satisfying your non-functional requirement regarding performance, then of course you need to stop there. There's no doubt about it. Okay, but usually it's statistically, empirically proven that not every part of the system is actually really contributing a lot to the performance. It's a very small methods, especially those methods, those classes which are dealing with your network communications, because network communications have a very huge impact on your performance. Or database communications, where you're sending SQL queries, they have impact on your performance. So as a result, if you focus your refactoring on those parts, probably you will get a lot of benefit. Everybody got this one?
Yes. Yes.
Okay, and of course, as we said on Sunday, and we are saying this again, always remember we are developers are always under pressure, right? So we are towards the deadlines. We're always trying to make our code work towards as close to the deadline as possible. We're still testing them. So we all, and this could be reason why sometimes we, might be slow in the beginning. Sometimes we have, tight deadlines and so on and so forth. So refactoring takes time. We should not rush to it. We should not be doing it close to the deadline. We should leave it once the delivery has been done. Again, the reason is we want to do refactoring on a stable piece of code. So we have done a delivery, we have released it, it's working fine, it has no bugs in it, it's satisfying the requirements. Now is the time to apply these refactoring, because you can take your time, you can organize them, make sure you don't have introduce new bugs in it, it doesn't break the external behavior of the system. So basically, it's a time consuming activity. That's why usually within even agile environment, you do it after sprint. So basically implement the functionality first, then you refactor it. And this kind of, it's almost time of the end of the lecture time as well. So basically it's a perfect timing. So we can kind of summarize what we have, gone through. As we said, there's so many tools out there now in the market which allows us to do these refactoring, Eclipse, NetBeans and GA refactory and so on and so forth. I encourage you guys to try to refactor your code. Once you have done with it, you have done it, delivered it, it will help you, better structure it and easy to understand, and someone else to read your code in an easier way. But you should not be doing this close to your deadlines. You should not be doing this when you're under time constraint pressures. You should be doing it once you're more relaxed and you have luxury of going on and refactoring it. In a summary, as Martin Flower's definition, process is all about making changes to software such that you don't alter the external behavior, yet you improve the internal structure. And we've seen some examples today: extract method, move method, pull methods up, down. All of them, helps you improve the internal structure of the system without altering the external behavior. Of course, refactoring have obstacles. There's no doubt about it. But the benefits are real. And as a result, it's highly recommended that once you are done with your release of the system, you have achieved the functionality, go and spend some time to refactor your code so that it's better structured. You remove these code bad spells, which can lead to potential problems later on, and so on and so forth. There are a lot of material available, by the way, on refactoring. All these books are there. And then, of course, this website refactoring.com is an amazing resource where people keep adding latest details and latest techniques and tools and discussion on what's happening in the refactoring. So if you're interested in refactoring as a domain, probably this is an amazing resource. So with this, alhamdulillah, we're done with our refactoring, material. We're almost in the middle of week 13 now, so coming towards the end of the semester. So inshallah ta'ala, on Thursday, we'll start our last topic for the semester for 316, which is software construction. So let me stop the recording, take the attendance, and of course, floor is open for questions.